Mastering cloud-native security. Cloud-native security principles upside down traditional approaches. Why do the key principles of cloud-native security, which prioritize scalability, automation, and agility, diverge from traditional security approaches that often focus on static, perimeter-based defenses, and what are the main distinctions between these two methodologies in terms of their conceptual frameworks, technological requirements, and operational implications? The key principles of cloud-native security diverge from traditional security approaches due to the fundamentally different design principles and architectural requirements of cloud-native applications. Traditional security approaches were formulated in an era of static, on-premises infrastructure, where security was primarily focused on protecting the perimeter of the network. In contrast, cloud-native applications are designed to be scalable, agile, and highly distributed, which requires a security posture that is equally adaptable and flexible. One of the primary distinctions between traditional security approaches and cloud-native security is the conceptual framework. Traditional security approaches are often based on a castle and moat mentality, where the primary focus is on building strong perimeter defenses to prevent unauthorized access. This approach relies on a defined boundary between the trusted internal network and the untrusted external environment. In contrast, cloud-native security recognizes that the perimeter is no longer a fixed boundary, but rather a dynamic and constantly shifting concept. Cloud-native applications often involve microservices, containers, and serverless architectures, which blur the lines between internal and external environments. As a result, cloud-native security prioritizes a zero-trust model, where all interactions, whether internal or external, are treated as untrusted and subject to rigorous authentication and authorization. Another key distinction lies in the technological requirements of traditional security approaches versus cloud-native security. Traditional security approaches often rely on network-centric security controls, such as firewalls, intrusion detection systems, and virtual private networks, VPNs. These controls are designed to protect the network perimeter and are often static, inflexible, and difficult to scale. In contrast, cloud-native security requires a more agile and adaptive approach, leveraging technologies such as cloud-native security platforms, identity and access management (IAM) solutions, and cloud workload protection platforms (CWPPs). These technologies are designed to provide real-time visibility, automation, and scalability, enabling organizations to respond rapidly to changing threat landscapes and evolving business needs. In terms of operational implications, traditional security approaches often require significant manual intervention, including configuration, management, and monitoring of security controls. This can lead to a high administrative burden, inefficient use of resources, and an increased risk of human error. In contrast, cloud-native security emphasizes automation, artificial intelligence, AI, and machine learning, ML, to streamline security operations and reduce the attack surface. Cloud-native security solutions are designed to be highly automated, allowing organizations to focus on higher-level security concerns, such as threat hunting and incident response. Moreover, traditional security approaches often focus on protecting specific assets or data, whereas cloud-native security takes a holistic approach, prioritizing the protection of the entire application and data workflow. This includes securing the development pipeline, infrastructure, and runtime environments, as well as ensuring the integrity and confidentiality of data in transit and at rest. Furthermore, traditional security approaches often lack real-time visibility and monitoring capabilities, relying on periodic security assessments and manual audits to identify vulnerabilities and threats. In contrast, cloud-native security emphasizes continuous integration, continuous deployment, C/CD, and continuous monitoring, CM, to provide real-time visibility and early warning detection of potential security threats. In addition, Traditional security approaches often rely on a hierarchical, top-down management structure, whereas cloud-native security encourages a more decentralized and autonomous approach, empowering development teams and DevOps engineers to take ownership of security and make data-driven decisions. Another key distinction lies in the approach to compliance and regulatory requirements. Traditional security approaches often focus on compliance as a checkbox exercise, whereas cloud-native security views compliance as a continuous process, leveraging automation and orchestration to ensure ongoing compliance with evolving regulatory requirements. Lastly, traditional security approaches often neglect the importance of cultural transformation, whereas cloud-native security recognizes that security is a business enabler, requiring a cultural shift towards a security-first mindset, where security is integrated into every stage of the application development lifecycle. In conclusion, the key principles of cloud-native security diverge from traditional security approaches due to the fundamentally different design principles and architectural requirements of cloud-native applications. Cloud-native security prioritizes a zero-trust model, agility, automation, and scalability, leveraging technologies such as cloud-native security platforms, IAM solutions, and CWPPs. The operational implications of cloud-native security include automation, AI, and ML, as well as a holistic approach to security, continuous monitoring, and cultural transformation. By adopting a cloud-native security posture, organizations can better adapt to the evolving threat landscape and ensure the integrity and confidentiality of their applications and data in the cloud.